Okay, I think we should start. It's that moment. Okay. Hello, everybody. Thank you for coming here. Oh, there's one bit late. Is your name Kostas? Oh, yeah, you are. You're a bit late, and we're waiting for you. Okay? So, hello again. I'm Tasos. I am a dancer. No, sorry, different audience. I'm Tasos. I work on backend and AI systems. And here we're here today because I want to show you a simple experiment. Okay? What happens if you let an LLM explain physics? And specifically, general relativity. I'm sure you're all familiar with the subject, right? Einstein's theory. Yeah? All of you? Who isn't? Who doesn't know anything about relativity? Again? Okay, you're gonna have a problem. But that's okay. You know, this is not the point of the presentation. And I'm gonna try to walk you through as easy as I can. Okay? So I have a question for you. Who has used LLMs in here, in this room? Can I see hands? Okay. 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 All the same. Okay, so this is the setup. Okay. We ask an LLM to generate a full presentation on GR. GR stands for General Relativity. Okay. Not assist, not summarize, just produce the whole talk. And the result is very interesting. It's fluent, it has structure, it looks good, but you know what? It's very wrong. It includes all the right topics, okay? Time dilation, gravitational waves, black holes. It includes citations, equations, everything you would expect from such a procedure, okay? But that's exactly the problem. And I'm going to show you what that looks like. It worked. Perfect. So, everybody sees what? Okay. So this is a really kind of explanation that the model produces, okay? So it says, gravity slows light, so time runs slower. It looks scientific, correct? It looks like it's written in a book of Einstein, okay? It uses real terminology, but the reasoning is very wrong. And what I mean by that is that, as we know, light is constant. It travels with constant speed across the universe. So, this is not correct, okay? So, here is one question that breaks most AI explanations. How would you measure that, okay? What observable changes, what instruments would you use? What would you compare? And the thing is that if you cannot describe a measurement, you don't have a physical explanation. Can you understand it? Because physics is, it doesn't lie, okay? I mean, it's not that simple. So now let's make this concrete, okay? For example, suppose you have two clocks, one on a GPS satellite and one clock on Earth, okay? Gravity makes the clock on the GPS satellite work faster and the clock on the Earth work slower. So GPS work because we correct them both daily, okay? And this is not from a nice story. It's because of measurement. Because we measure the difference and we find out that in distance perspective, it's about 11 kilometers per day. So I want you to think, to take a second and imagine how crazy that is, okay? So this is not theory. This comes from measurement. This is pure engineering. And if we didn't make corrections, GPS would fail. So, oh, sorry. I think I passed one slide. Yeah? Yeah. So this project, this idea, evolved from something simple like generating slides, generating a presentation, into something more deep, something different, like a reliability pipeline. Okay? We don't trust the model. We just build a system around it. Okay? We generate, we validate, we check and fix. We start from sources like scientific papers, scientific articles, anything you would like. Okay? And then the model produces a structured deck of slides. What happened? Did we okay. So the model produces a structured deck of slides. And, oh, sorry. Nobody told me. Okay. So we start from structure, okay? If it cannot parse, it cannot ship. Meaning that we force the models to output structured JSON data, okay? And this let us validate, repair, and automate checks. It doesn't guarantee correctness, okay? It's not something like that, but it makes failures more visible and more testable for us. And for example, I gave an input that says I want that kind of slide with that formation, that title, that subtitle, that content, a comment, sorry, citation reference, equations, and we can validate the structure by that. Okay? And then we add. Is it a good now? Is it a good? Okay. So, I'm sorry. I can handle myself. So then we add a physics linter. It's hard-coded rules, okay? You can imagine that like code linter. So those hard-coded rules are there to catch errors that, you know, are obvious, right? For example, if you say that, I mean, not if you say, if you try to explain time dilation without clocks, you fail, okay? If you try to explain gravitational waves without wavelength measurement, you fail. And if, for example, you say that black holes are sucking everything around them, you're very, very wrong, okay? So, these rules catch automatically many errors, but this isn't enough, okay? And you know why? Because, first of all, passing rules doesn't mean understanding, and second, because passing rules doesn't mean that explanations are actually correct, okay? That is why human review and presence must be in the loop. Okay? The expert must be there to handle those errors, to see them, to catch them, because they're not easy in the eye. For someone that doesn't understand physics deeply. Okay, by the way, I'm a physicist, so I know what I'm talking about. Okay? I just want to point it out because it's not that obvious. Okay? So we need more than rules. We need something like an iteration. Okay? We need a loop. So we generate, validate, critique, and revise. So the system loops until it improves output. Okay? We don't trust the system. I'm going to say it again. We don't trust, the system, the model. I'm sorry. I'm going to say it again. We don't trust the model. Okay? We just loop until it stops failing. And here you have it. What happened now? Okay? We run the pipeline, and on the first draft, we get 6 failing slides. And after the refinement loop, we reduce that to 4. Okay? It doesn't solve correctness. Okay? We didn't solve reasoning, but we made it more measurable. Would you trust something like that? Hans? Hans? Would you trust something like that? No? No hands? One? Okay. So, let's all say hooray, right? The system, the model improves itself, the pipeline works, okay? But this is not enough. And yet, some problems still remain. I mean, it's not that perfect after all. Okay, citations look correct, but don't support claims. Explanations pass rules, but they are still vague. So another thing that is very difficult for moderns is frame confusion. And what I mean about frame confusion is that the model mixes perspectives into one explanation. Okay? So what did we learn from all of that? We learned something, right? We learned to treat LLM output as an unstructured input for us, okay? And we build a system around it because we want to have control. And if you are a control freak like me, you want to have that because you want to do your job, you're going to know what it's outputting, you're going to have, I don't know, you're going to be the hand of God, let's say. So we add 4 things. We add structure, we add domain rules, we add critique loops, and the last and more important, I think, we keep us humans in the loop. Okay? Because you know what? LLMs are incredibly good. I mean, incredibly good, and I can see it every day in my daytime life, okay? Of sounding right. But sounding right isn't the same as being correct, okay? Because you know what? AI is fluent, but reality isn't optional. So the whole outcome of this talk, of this project, of this process, if you'd like, is that if you cannot measure something, you and your AI cannot understand it. So the whole project that the presentation is all about, I've uploaded in this repo. You can find it through this QR code. Okay, it has full documentation, full architecture. Don't hesitate to contact me for any reason. And my personal info is there. So I think you can see it. Okay, so you can play with it, right? You can replace it with your own domain, not physics. You can do medicine, for example, and change the constraints, see how that goes. And at the end of the day, just have fun. Thank you, guys. Thank you so much. Okay. I don't have time for questions, but let's go. Do you want a microphone? Do I have time? Do I have time? Do I have time? Do I have time? Ah.
If you can move the cursor from the QR code.
I thought it was gonna be a question. But do you have any questions? Anybody? Can I take a picture of you? Is that okay? Can I take one? Anybody has an issue with that? Okay. I'm gonna take a selfie. Like a real OG. Thank you so much. Any questions? No questions? Perfect. Ah, you have? Yeah. Let's go, why not? Yeah, the example was about the clocks, okay? Because the AI told that, you know, light slows down, which is not correct. So the example was about clocks that we measured, and we saw that it wasn't the same time. So it's not about something time, because it referred to time dilation, okay? Do you know about time dilation? Do you have the concept? I mean, okay, you can think about space-time, okay? Let's say we have a planet. It creates gravity around it, but that is not a force, okay? It's geometry. Okay, if light passes through that object, not through, passed by, okay? It seems, for an observer outside of that place, that light slows down. But that is not the case because it travels more space due to curvature, okay? Because light travels with the same speed at all times, anywhere. Do we got it now? No?
I was asking about, I understood that your point of this presentation.
Yeah.
In general, how to measure the output of an LLM program.
Yeah, I mean, because it had to explicit. Okay, it's not about the measurement, I mean the model, how to measure it, okay? It has to tell me that, you know what, this is not actually correct because we have to have two clocks, we have to make a measurement. I mean, the whole talk is not about physics, per se. It's about the human presence in the whole loop, because the model has to be, at least for me, and for the presentation, has to be in a loop. I mean, it has to be one thing. Everything else, it has to be controlled. It has to be a system to validate, to set up rules, okay? And have more control around it. Because if I didn't know physics, that would be correct for me, right? And for specific fields like physics, medicine, I mean, if you ask him about dosages for medicine, would you trust it? If you didn't know the field, that's what I'm talking about. Yeah. Okay? Thank you guys again. I'm gonna be here for the next talk also. Let's go again.